So when dealing with the questions of trapezium rule, we begin by relating what has been given to the original expression that must be solved using trapezium rule. So the question says, use trapezium rule with 7 ordinates to estimate the integral correct to 2 decimal places. Like we said earlier, if the question says that the final answer of the integral must be to a minimum or to less than 4 decimal places, then all the y values must be recorded to at least 4 decimal places. So we shall see that when it comes to the determination of the y values. Now, the integral which has been given is an integral from 0 to 3 of this function dx. But then when we were starting, we began with this. We said trapezium rule can be used to generate the value of the integral from a to b of a function f of x with respect to x. So what you do, you relate the integral given. Our integral given is this one. It is an integral from 0 to 3 of 1 over 1 plus x dx. So you relate it to the original one, which is an integral from a to b of f of x dx. Why relate it? It is because we want to read off b and a, and then we substitute them here to get the value of what? H. So we are now relating this integral to the original one. So our integral is an integral from 0 to 3 of this dx, which we are relating with the integral from a to b of f of x dx. Now the next thing is to compare and read off the values. This is 0, this is a, it means a is 0. This is 3, this is b, it means b is 3. This is dx, this is also dx. This is f of x, and this is 1 over 1 plus x, which means our f of x is 1 over 1 plus x. But you will recall that we said f of x, which is always provided there, is always a y value. So a y value is a function of f of x. So having spotted f of x, we are now letting our y to be f of x, which means instead of saying f of x is equal to 1 over 1 plus x, we shall instead say y is equal to this guy, because y and f of x they are the same things. So our a is 0, our b is 3, and y is 1 over 1 plus x. Now, having obtained a, b, and y, the next step would now be getting h. So before you get h, you first ask yourself, is what has been provided, or what have been provided, ordinates or subintervals? You recall that h is b minus a over n, where this n is number of strips or subintervals. Now the question has provided ordinates. So we are going to say 7 minus 1 to get 6 subintervals. After getting the subintervals, we now substitute here. Our b, we already read it as a 3. Our a is a 0, and our n is now a 6, which is 3 minus 0 over 6, and that gives us a half. So before proceeding to the table of values, you first ask yourself, when I put this half in the calculator, do I get a terminating decimal or a non-terminating decimal? How do you know that it is a terminating decimal? You will know that it is a terminating decimal if after putting it in the calculator, it has very many values, which are almost exhausting the entire screen of the calculator. Then you will know that it is a terminating if after putting it in the calculator, you get you get a value which has 1 or 2 decimal places. So if your answer has 1 or 2 decimal places, then it is better to take h as that decimal, or you can even take this one. The logic does not change. But where h has very many decimal places, then the best thing to do is to take the fraction and then you generate the corresponding values of x. So having gotten our h as a 0.5, we now go on and get the x values and their corresponding f of x values, or their corresponding values of y. We begin with the x values. The x values must run from the lower limit of the integral up to the upper limit of the integral. But we generate those x values using h. So my h is a 0.5. Since h is a 0.5, it is 0.5. You ask yourself, what is the lower limit of the integral? It is a 0. It is the starting value here. Now, after writing the lower limit of the integral, you just pick it from the integral given. It is 0. You write it here. Now, you keep on adding 0.5 on this lower limit until when you get the upper limit. For example, my lower limit is 0. Plus 0.5, we get 0.5. Plus 0.5, 1.0, 1.5, 2.0, 2.5, 3. If you reach the upper limit of the integral, you stop. It means that you have exhausted all the x values using h. Now, having obtained all the x values using h, the next step is now to use this function where y is equal to 1 over 1 plus x to generate the corresponding values of y. So, we are going to separate our table into two partitions. The reason is because our formula dictates. The formula says that since you have h, you will divide your h by 2. You add y naught and yn. Y naught is the y value of the first x value, and yn is the y value of the last x value. We are supposed to add them separately. Then all other y values must be multiplied by 2 after summing them up. So it is the essence of having these two partitions. So that after getting the y value of the first x value and the y value of the last x value, you add them together, you get that sum. You also deal with the y values of the middle x values, sum them up and get their total. Now, how do we get these y values? Before getting the y values, you first ask yourself, is my expression of y containing any trig function? If it contains the trig function, you get your scientific calculator and you change the mode to the rad. You change the calculator to the mode of radians. And if your function of x does not contain any trigonometric expression, for example, this one, it is free from any trig expression. So it means you can leave the calculator in the mode of degrees. So ours is not containing any trig function, and therefore we shall use our calculator when it is in degrees. So having obtained the x values, you pick one x value at a time and you substitute it where there is x. For example, when x is 0, y becomes 1 over 1 plus 0, which is 1. It is this. When x is a 3, you go to where there is x in this function, in this expression of y. Where there is x, you put there a 3. So it becomes 1 over 1 plus a 3, which is 1 over 4, and that is a 0.25, which is this. We are recording them to 4 decimal places because we don't want to forget that if the integral is required to less than 4 decimal places, all these y values must be recorded to a minimum of 4 decimal places. So having obtained the y value of the first one and the y value of the last one, you now draw this. You add this plus this and get this one. Now you follow the same procedures and you get the value of y when x is 0.5. So when x is 0.5, you go to this expression of y. Where there is x, you put there 0.5 and you definitely get this. You do the same for this, and that, and then you sum these ones up, you end up with this. So having obtained the values of y for all these x values, this and that, we now substitute them in our final rule of the trapezium. So where there is h, we are going to put the 0.5 and it is so where there is h, we are putting 0.5 and we are dividing it by 2. Now where there is y naught plus yn, we are putting this value here, which is the sum of the first y value, which is the sum of the first y value and the sum of the last y value. It is this. Then where there is 2 times the sum of the other y values, we are going to get all our middle y values are these, and their sum is this. So we are going to get a 2 and we multiply it by this guy. So if you get a 2 and you multiply it by that guy, you will definitely have this. And after getting that, you must record it, the number of decimal places which are quoted in the question, and the question wanted our final answer to 2 decimal places. So after the decimal point, we are going to count 1, 2. So you draw a line here, and because this is a 5, then we add a 1 on the previous value to make it 1.41. We are putting square units because we are finding the area of the curve and using the trapezium rule. So it is the essence of putting square units. Then in question 2, they are now giving us an expression that has a trigonometric function, and we are noting that if the integral given has a trigonometric expression, then you must change the calculator to the mode of radians or rad. So you press the mode button on your scientific calculator until when you see this word rad. When it happens, you press, or when it surfaces on the screen, you press the digit below it, and the calculator will definitely go to the mode of radians, and then you calculate accordingly. So even in this case, after converting your calculator to radians, when you write the integral given, you also write the original expression. So our integral is from 0 to pi of this dx. We are relating this to the integral, which is from a to b of f of x dx. We shall not always forget that y is a function of x. So since y is a function of x, it means our y is this guy here. So which is 1 plus sine x power a half, which is as good as having the square root of this guy. So my a, when we compare this and this, my a is 0, my b is pi. So a is 0, b is pi. Now we go to h. In h, this n must be number of sub-intervals. So if they give you ordinates, you subtract 1 and you convert them to sub-intervals. So my n becomes 6. That is after saying 7 minus 1 to get 6. Why subtract 1? Because these are ordinates. If the question was saying use trapezium rule with the 7 sub-intervals, we wouldn't have subtracted anything. But because it is saying ordinates, we are supposed to subtract 1, because what must be placed below here should always be the sub-intervals. Now our h is pi over 6. This time when you put pi over 6 in the calculator, you will get an answer that exhausts the entire screen, and we don't want such decimals. We said if that happens, then we adopt our h when it is in form of a fraction. So our h that we are going to take is pi over 6. You begin with the lower limit of the integral, which is a 0. After writing the lower limit of the integral, you keep on adding h on the x values that you get until when you get pi. So our first one is 0 plus h plus pi over 6, we get pi over 6. Plus pi over 6, we get 2 pi over 6. Plus pi over 6, we get 3 pi over 6. Plus pi over 6, we get 4 pi over 6. 5 pi over 6 until when we get the pi, which is here. So after getting the upper limit of the integral, you definitely stop, and those would be your x values. So having converted the calculator to radians, when x is 0, you set the square root, you open the bracket of 1 plus sine of 0, you'll get your answer as that. The same applies to all these ones. You say, what is the square root? You open the bracket of 1 plus sine of pi over 6, you close. Or you can say the square root of 1 plus sine, open, pi over 6, close, then you close, and you press an equal symbol, an equal sign symbol. You will definitely get your result as this. So you do the same as we have explained earlier. The y value of the first x value and the y value of the last x value are separated from these other y values. So it is the essence of having this guy here and that guy there. Then the other y values are put aside because you will need their sum separately. And their sum was definitely that. So if you want to easily see how we have obtained these y values, you'll get your calculator and say, when x is 0, you go to the function of y. Where there is x, you put there a 0. Then you say the square root of 1 plus sine of 0. You'll get this. The same applies to all these x values. And you'll definitely confirm. So it is the essence of these guys in the corner here, for you to see how we definitely get the y values using the x values. So if you do all that, you will have obtained this and that, which are very crucial when getting the the values of the integral. So y naught plus yn, they are the values of the first column, the sums of the first column of the y values, which is this, and it is 2.00. Then all of the other y values, we multiply them by 2, and we shall have that. So if you work out where there is h, we put there our value of h, which is pi over 6. So if you substitute all that in the formula, you will definitely have your final answer as 3.98. We are putting 2 decimal places because the question wanted the final answer to 2 decimal places. But what is very important to note in the second example is that if what is here has anything to do with a trig function or expression, it might be cos, it might be sine, it might be tan, it might be cot, it might be cosec, or it might be sec. Then the calculator must always go to radians before putting anything in it. If you use it when it is in degrees, you'll be getting wrong values of y. So let us take note of that if this guy has anything to do with a trig expression, then we must always put our calculators in radians. Now, in some questions, they may not give us that use trapezium rule with the 7 ordinates or these sub-intervals to find the value of the integral. They may instead say use trapezium rule with a class with a width, or using a width of pi over 6. Use trapezium rule to find the value of this correct to a given number of decimal places. So the width that they talk about is the value of h. So when they give you the width, you simply get the first value here, put it here, you keep on adding that width until when you get the maximum value. So the width and h, they are always the same, and the class will definitely meet that in the exercise or assignment that we shall have at the end of the discussion of this. So if they say using a class width of this, then we do not waste time. It means that is our h. So we get this. Sometimes this one is not a 0, so it is not a must that it will always be a 0. But whatever is here is what you begin with. In this column of the x values, you write it, then you keep on adding that h until when you get this. So if they deny you this and instead give you the class width, then it means they have calculated for you this h. So you use that h, get these ones, and the rest remains. Now the other way they can hide this is when they give you a table that has the x values and f of x values, and you're supposed to use trapezium rule to get the the value of the integral of any given function. Now in example 3, we want to see that case. If they give you a table of values that have the x values and the f of x values, the logic does not change. We always suppose that our y is this f of x. You let y to be f of x, then you separate these things. You redraw this guy and you put the x values separately, then the y values separately. The first one is a 0, the last one is a 2. So we add this and this separately. Then all these other middle x values, we also put their y values aside and we work out. So this is what we are referring to. That after drawing, if this is x, we have 0, a third, 2/3, up to 2. 2/3, there is 1, and so on up to when you reach a 2. Then we have the y values this side. We have the y values this side. So you separate here. Put here the value of y when x is 0. Put here the value of y when x is a 2. After doing that, then sum them up. Get your sum there. All these other y values which are lying in the middle, you begin with 1/3. You write it here, 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 up to here. Then you also sum them separately and you put their sum here. This is for the extreme y values. This sum is for the middle y values. All these y values in the middle here, you sum them up separately. Then you also sum this and that separately. Then you substitute them in this original expression. Now on substituting in the original expression, you realize that h is nowhere to be what? To be seen. So if h is nowhere to be seen, then it means you go to the table of the x values and you pick any 2 successive x values and you take their difference. For example, our x values are here. You pick any 2 successive. If you take their difference, what arises is the value of h. So if you say a third minus 0, it is a third, implying that our h is going to be a third for this question. So you put here a third, you substitute this as a result of adding this guy and the other one. Then you also substitute this as a result of adding all the middle y values, and then you'll definitely get your final answer. So if you do that, you'll check and see whether the answer is going to be 0.33 and a 5. So those are the other 2 ways of how they can set a question on trapezium rule. So they will either say using a class width. If that happens, we said we do not recalculate the h. It means we use the h which is quoted, and then we generate the x values. If that does not happen, they will use this guy of the table, and if they use the guy of the table, we said you pick any two consecutive x values, get their difference, that would be h, then add this and the other one separately, and also the middle values, and you substitute in the original rule of the trapezium. And if you do that, you will have grasped everything to do with the trapezium rule. So we have said if the function does not contain any trig expression, the calculator remains in degrees, and if the function has any trig expression, the calculator must always be changed to radians before getting the values of y. We have also said they can give you a table. If they give you a table, that is the logic that you follow to get the the value of the integral. If they deny you a table, but instead they give you an expression and also the width plus the x values, when they have not given you the intervals, then you can always calculate using the width. We said by you pick the lower limit of the integral, you keep on adding the width until when you get the upper limit of the integral, and that such a question will be seen in the exercise, which is probably coming after all the explanations on the trapezium rule. So you can try out, and you always forward your questions to this email or that WhatsApp number. You can always keep in touch by subscribing to the YouTube of Mutiaba Asuman. So you can check and then you subscribe to that YouTube. Thank you for listening. We shall meet in our next series, which will be about how to get the absolute errors, the percentage errors, relative errors using the trapezium rule. Thank you for listening.